Okay, so in example 5, what I'm going to be doing is continuing to work some examples where we find the volume of a solid by rotating a particular region. Now in this case, this was the example I didn't have time to get to in class, so we want to find the volume of the solid that we're now going to be rotating the region that was from example 3, but we're going to do it about the line x is equal to -1. So let me just back up real quick and show you the region. In example 3, we were looking at the region bounded by the curve y is equal to x squared, which is this arrow r that I've pointed to here, that region right there. But now instead of rotating it about the x-axis as we did in example 3, or even the y equals 2 line like we did in example 4, we're going to come back and do x equals -1. So let me begin by drawing my region here. Now I'm going to need to come far enough over so that when I draw my vertical line at x equals to -1, I have enough space to mirror around. So remember, I'm going to go from 0 to 1. It's a straight line that goes up from the origin out to here, and then it's the parabola. I'm going to draw faster, or it thinks I'm double clicking. Okay, and now I'm going to do the same thing over on this side. So I got to mirror image this thing. Notice the bottom point here is 1 away from this x equals -1 line here. So I'm going to start here, and I'm going to go a unit 1 away from there. And I'm going to need to go up, because I like to mirror the 2 endpoints. So I'm going to go, remember, 2 away here. So I'm going to go 2 away there, here. And so I've got a straight line, and I've got my parabola right there. And again, remember, this is rotating about here, so it's going to be this kind of bowl shape. Actually, it looks very much like a cereal bowl to me. So what I do is I pick a particular y, and as I go out in each direction, I'm going to have a cross section that again turns out to be, I just got to stop doing that, an outer circle and an inner circle. Now what we've got to be able to do here is measure the outer radius from the center and the inner radius. Okay. So in this particular case, the outer radius is going to go from here, that is the x equals -1 line, all the way out to this curve. Okay, so the question is, how far is that distance right there? Well, since this curve right here, right, is the length for that given y, it's the value of that curve. Now remember, y is equal to, from the previous one where we rotated about the y-axis, which we did, didn't we? Nope, only x-axis. Okay. Well, remember, this curve is y is equal to x squared. So what we need to know is, what is x as a function of y? So that says x is equal to the square root of y, just taking the square root of both sides. Okay. So it's this distance from here over plus the distance out to the function. So the outer radius will be 1 plus square root of y. So that's the function of the curve on the outside as a function of y. So we pick a y, we need to plug the y in, so we need to know what is this as a function of y. So that's why we solved it for x. Now the inner radius will be almost exactly the same thing. So now I'm going to go from this point out to here, and then I'm going to go to the point on that line. Now that line, remember, is y is equal to x, which is the same thing as x is equal to y. So my inner radius will be 1 plus just y. So my area, in fact, let me give myself a little bit more space here. I'm going to go back and start writing in red again. My area of this annulus is pi times 1 plus square root of y squared plus, minus the inner radius squared, pi times the inner radius squared, 1 plus y squared. Alright, and now I'll simplify this with a little bit of algebra. Keep in mind 1 plus square root of y squared has to be FOILed, so I'm going to bring my pi out front like I did in the previous example, and now say 1 plus 2 square roots of y plus square root of y squared, which is just y, and then this is 1 plus y times 1 plus y, which is 1 plus 2y plus y squared, but then there's a minus out front, so minus 1 minus 2y minus y squared, and the pi I just pulled and factored out. So the 1's cancel. I've got a 2y and a minus 2y, sorry, y and a minus 2y. So I end up with 2 square roots of y minus y squared, all times pi. So the volume will be the integral of that area function, 2 square roots of y minus y squared, from, and now the y, which I chose right here, is going to range over that entire interval, so from 0 to 1 dy. And there's my integral. Alright, which we can then evaluate. We'll do this relatively quickly. So this I'll treat here as y to the 1/2 power. So that's pi times 2 times y to the 1/2, so pi, and then 2 y to the 3/2 divided by 3/2 is to multiply by 2/3, so that becomes 4/3, minus y squared over 2 minus y cubed over 3 from 0 to 1. So that gives me a pi times 4/3 minus 1/2 minus 1/3. That's a 4 there, sorry. 4/3 minus a third is 1. 1 minus a half is a half, so that gives me just pi over 2 is the value of that integral. And that is all for that example.